Hi friend, welcome again. In our previous lecture we have discussed about feedback and type of feedback. Now in this lecture we will discuss about negative feedback in detail. So we'll gain in negative feedback. We have calculated that a dash is equal to a prime equal to a upon 1 plus a beta and a prime is less than a, where a is the gain of amplifier in normal case and beta is the amplification factor for feedback element, and this is our output terminal and this is our input terminal, and the phase is negative for feedback and positive for input. In this case we have calculated that our gain is a prime equal to a upon 1 plus a beta, where a prime will be less than 1 because we are dividing a with a quantity greater than 1. Now we are using negative feedback, so there will be some reason behind it. So next point is advantage of negative feedback. So next point to discuss is advantage of negative feedback. We are using negative feedback element in our amplifier, then what is the basic reason behind it that we are using negative feedback? So it can be explained by, in this amp feedback circuit only gain is being reduced but stability factor stability gain increases. It means that the stability of negative feedback amplifier or the stability of the circuit due to negative feedback increases. How? We know that a prime is equal to a upon 1 plus a beta. So here a prime is the function of amplification factor a. Suppose there are some change in our amplification factor, in that case there will be change in the a prime also. So differentiate this equation with respect to a and divide with this equation, again we will get change in a prime upon a prime is equal to 1 upon 1 plus a beta square time of change in a upon a. So that's why here we are dividing this with 1 plus a beta square, so that's why its value become very less. So due to the change in open amplification factor a, there will be a small variation in a prime. That's when percentage change in a prime is very less than the percentage change in a. So the stability gain increases. Now second point is It increases the bandwidth. It increases the bandwidth. In case of amplifier, we desire that our amplifier should be able to operate on every frequency. So that's why we are using negative feedback. In that case, it will be increases our bandwidth, and we know that the bandwidth is nu 2 minus nu 1, where nu 2 is upper cutoff frequency and nu 1 is lower cutoff frequency. Suppose after feedback cutoff frequency became nu 1 dash, nu 1 prime and nu 2 prime. In that case, the value of nu 1 prime will be equal to nu 1 upon 1 plus a beta, and nu 2 prime will be nu 2 1 plus a beta. So that's why in case of negative feedback, value of lower cutoff frequency decreases while value of upper cutoff frequency increases. So bandwidth in normal case is V nu 2 minus nu 1. So bandwidth in feedback became V2 into 1 plus a beta minus V1 divided by 1 plus a beta. It's mean that BW prime bandwidth after feedback is greater than bandwidth without feedback. So here we have discussed two advantage of negative feedback. One is the stability gain increases, or the stability of the amplifier will be increases, and another factor is bandwidth of the amplifier also increases. Now third point is it gives less frequency, amplitude and phase distortion. It gives less frequency, amplitude and phase distortions. Now it reduces the noise given by amplifier. It reduces the noise given by amplifier. See, if we are seeing the graph of noise, a variation without feedback, this is our output or response without feedback, and we are taking response with the feedback. In that case, here the change is linear. Now it becomes some straight due to small gain. So the graph becomes somehow linear in a proper way, so the distortion will be less. While gain of an amplifier will be reduced, so that's why there will be small variation in its output, so that's why noise will be reduced. Now it increases the input impedance and decreases the output impedance. Next point is it increases the input impedance while decreases output impedance. Now let R input is input resistance without feedback. So R input prime after feedback will be R input time of 1 plus A beta, and if R output is output impedance without feedback, so R output prime, that's mean output impedance after feedback will be R output upon 1 plus A beta in negative feedback. Here input resistance increased by 1 plus beta times and output resistance decreased by 1 plus beta time, and same in the case of cutoff frequency. So that's why we can say that negative feedback is only reduces the gain of amplifier, but it increases other factor which is necessary for our circuits, such like stability gain, high stability gain, and the stability bandwidth of the circuit becomes high. It decreases the frequency, amplitude and phase distortions. It reduces the noise gain. So negative feedback is useful. Now we will use negative feedback circuit for our analysis. In that case, there will be combination of the elements. Suppose we have any kind of amplifier like this. It will consist two port. This is an two port element which is also known as two port network. Here I am showing an amplifier having two port. This port of left side is representing input port and right side is representing output port. Generally, we will use the sign convention that upper is positive and lower is negative, and same here, upper is positive and lower is negative. So there will be some consideration about this. We can take output for our feedback in the form of series or in the form of parallel, and same here, we will provide input combination in form of series or in the form of parallel. So there will be different type of feedback circuit. So next point is various type of feedback circuit. Now this is mixing or summing terminal. In the feedback element, see here, this is your amplifier. We are providing feedback from output. This is your output, this is your input. So it will be taken in the form of series or in the form of parallel, and here we will provide input at the mixing terminal in the form of series or in the form of parallel. When we will supply series, in that case there will be input of voltage, and when we will connect parallelly, in that case there will be input of current. And in case of output, we need a constant output, so that's why if we are taking our output in parallel combination, so it will be voltage, and when we will consider only series combination, then it will be current. Now here at mixing point, we will use series combination, series feedback. That's mean here we are adding our input and feedback signal in series form, and this one is also taken in the series form. It means that this is your amplifier. It has two port element. Output terminal. This is your input terminal. This one is our feedback element having feedback factor beta. Now we are using series combination. In that case, the positive of this circuit is connected with its negative, and also positive of this is connected with the negative. So its plus is connected with the minus of the feedback, and its minus is connected with the plus of this feedback element, and same here, positive will be connected with the negative, and also here positive is connected with negative. See here, combination is series. In that case, in case of series, current will be constant, only voltage will be variable. So voltage will be added here for the feedback, and here we are taking the series output, so that's why we are taking current. That's mean it's providing current, and here we are changing voltage. It's mean that in case of series there will be change in the adding or summing in the value of voltage, and here we are taking output in the form of series, so that's why only current will be constant, so that's why we are measuring here current. So it is current series feedback, or also it is known as series current feedback. Okay, and this one is VCCS, voltage controlled current source. It's mean that it's providing us output in the form of current, but its value is dependent on voltage. And also it is known as another feedback element, like here we are taking current and we are giving voltage, so that's why output and input ratio will be in the form of output current upon input potential. So ratio of current to the voltage is known as conductance, but here we are taking the ratio of output current to the input voltage, so it's also known as transconductance amplifier. This is transconductance amplifier. So series feedback is also known as current series feedback and also known as transconductance amplifier. Okay. Next type of feedback circuit is shunt feedback. In case of shunt and shunt feedback, input and output both this is your amplifier having gain factor A, positive terminal, negative terminal, positive terminal, negative terminal. This is your positive terminal, this is negative terminal. Now in case of shunt, the positive will be connected with the positive and negative will be connected with negative. In this case, combination will be in this manner. See, in case of shunt, shunt feedback, here current is being added, that's mean current is as input, and here we need a constant output, and in case of shunt there will be constant output of only voltage. So shunt feedback is also known as voltage shunt feedback. Voltage shunt feedback. See, the naming is assigned that we are taking output voltage and the input is in the form of shunt combination, so that's why it is known as voltage shunt feedback or current voltage feedback. And here we are taking our output in the form of voltage while input is in the current, so the ratio of output and input is the voltage upon current, so it is resistance, but output voltage to the input current, it is also known as trans resistance amplifier. See, the value of voltage is dependent on this input current, so that's why it is current controlled voltage source. That's mean current controlled voltage source, because the value of output voltage is dependent on input current. Now, next type of feedback is series shunt feedback. So, series shunt feedback, input is in the form of series and output will be in the form of shunt. It's mean that this is input is voltage, because in case of series the voltage will be variable, so input will be voltage, and shunt output will be voltage, so it is voltage feedback. It's known as voltage series feedback, in which the value of voltage is dependent on the voltage, so that's why it is voltage controlled voltage source, and also it is known as voltage amplifier, because input is voltage, output is voltage, so that's why voltage amplifier. Now, we have an amplifier of amplification factor A. Its two port terminals are given as upper one is positive, lower one is negative, and same feedback element has upper positive, lower negative. Now, the connection is in the form of series and shunt, so that's why its positive is connected with the negative and its positive is connected with the negative. So, this combination become series combination, and here output should be shunt, so that's why positive is connected with positive and negative is connected with negative. And here we will take output V output, because only voltage will be constant, so that's why we are able to measure the voltage. And this is series shunt feedback or voltage feedback or voltage series feedback or voltage amplifier. Here the value of output voltage is dependent on the input voltage, so that's why it is known as voltage controlled voltage source. And fourth one is shunt series feedback. See, in case of shunt input, there will be input of current, because voltage will be constant, so that's why there will be no fluctuation in the voltage, so only feedback element is changing its current, so it is giving us current. And when we are measuring our output at output terminal, that should be in series form, so it will be current, because In series, current will be constant and the constant value can be measured. So, this is known as current feedback or current shunt feedback. It means output should be current and input should be in the form of shunt, or it is also known as current controlled current source because its value is dependent on input current. So, that is why it is current controlled current source, and also it is known as current amplifier. So, current mixing, current sampling feedback. In this case, the circuit will be, this is our amplifier, this is our feedback element, input is in the form of shunt. So, that is why its positive is connected with positive, its negative is connected with negative. Positive, positive, negative, negative. So, that is why value of current will be changed at the input, while output is in the form of series. So, that is why its positive is connected with the negative and its negative is connected with its positive. Always remember that upper terminal is representing only positive and lower is representing negative. So, this feedback is shunt series feedback. So, in this lecture we have discussed about negative feedback gain and its advantage of negative feedback, such like stability gain increase in the bandwidth, it will gives less frequency, amplitude and phase distortion, it reduces the noise because there should be some linear response, it increases the input impedance and it decreases the output impedance. In case of voltage input and voltage output amplifier, there we need high input impedance and low output impedance, because due to high input impedance the input voltage loss will be very less, that means all the voltage will be transmitted towards the output, and if the output impedance is very low, in that case output value of the voltage will be high due to low loss. So, always voltage controlled voltage source consists high input impedance and low output impedance, and on this basis we have discussed about various type of feedback circuit on the basis of combination of the network series feedback or voltage controlled current source or current series feedback, or it is also known as transconductance amplifier, shunt feedback, that means voltage shunt feedback, or trans resistance amplifier in which the output is taken as the voltage and input is provided in the form of current due to the combination shunt and shunt feedback. And similarly we have discussed two other amplifier, series shunt feedback, voltage feedback also, or voltage input voltage output feedback, or voltage series feedback in which the voltage controlled voltage source, this is also known as voltage amplifier, in which the input is in the form of series but output is in the form of shunt. What shunt is representing only parallel combination and nothing to worry about it, that it is a parallel combination of the ports of any element. Now, so we have dealt with the advantage and the type of feedback. Now, in next lecture we will deal with the impedance in various type of feedback element and other things. Thanks.